Hey everyone, AMR back again with another LeetCode video. So in today's episode, I'm probably just going to end up grabbing a random one. I do want to do a humble plug on the channel right now. I am doing a giveaway. The giveaway is for a signed linebacker legend Mike Singletary jersey. He was part of the '85 Bears. He is a absolute legend in the scene of football. I'm just giving it away. I'm trying to grow the channel. I would love for this to be my full-time gig. I feel like I have so much fun recording, not so much editing, but I am having a fun time doing my recordings and getting some content out there. But as always, if you like today's episode, feel free to like, comment, subscribe. It helps me out a ton. Let's go ahead and jump into some problems here. Okay, so I guess we can go ahead and handle this one. It is an easy problem. So essentially what you're going to end up doing here is you're given a large integer represented as an integer array digits, where digits sub I is the ith digit of the integer. The digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. This is like a problem that I don't really see ever happening in the real world. But essentially what you're doing is you're taking this number, converting it to 1, 2, 3, and then you are adding 1 to 1, 2, 3, giving you 1, 2, 4. You are then breaking up that into a new array, and so on and so forth. As you can see down the line here, the one caveat is that if you have a number that gets bumped up to an extra digit, then you need to unpack them as 1, 0. That totally makes sense. I'm not surprised by this problem at all. Let's go ahead and knock this one out pretty quick, actually. So we are going to say our converted digits is going to be dot join digits. Okay, so what that's going to do is it's going to take the list of integers and it's going to turn that into a string. You are then going to say int. You're going to wrap that. And then you are going to converted digits plus equals 1. Now you are just going to return the converted list back into a list, essentially. So what you want to do now is you want to convert this to a string. So you'll say string converted digits. So now you have a string value. You want to do a dot split on them by nothing. What that's going to do is it's going to split all of them individually. And then you just want to return 4x in, bam, and this should run smoothly. Okay, so ran into an issue here. Sequence item 0, expected string instance int found. Okay, dot join digits. Digits is a string. So kind of abandoning this up here, I think that I can do converted digits is equal to an empty string. And then you can do for elm in digits, converted digits plus equals the string value of elm. Okay. And then you want to go ahead and convert string, converted digits equals int, converted digits plus 1, blah, 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 and so on and so forth. String, so 4x converted digits. So you're turning that into a string, then you're splitting it up. Why are you putting it into a string. I mean, you could literally just go like this, and then you could go int of x. It's confused what I was doing there. Didn't really make a ton of sense, but it is now processing. Our solution was 84.44% faster than all Python 3 submissions, and it was 96.93 more efficient on space. Makes a ton of sense, honestly. Like, I can give a higher level overview of what I'm doing here. So essentially, you're giving that list of integers. You're taking a temporary value and setting it equal to an empty string. You're iterating over that list. So you are going to have a runtime complexity of O of n. And then you're going to iterate all over those elements. You're going to convert them to strings, add it to the list, convert that back to an integer, add one to the existing converted integer, and then do a list comprehension returning where you are just recasting it back to an int value for each element in that string. So there's that solution. I guess we have time for one more. Let's go ahead and jump into another one. Okay, so this one looks pretty easy as well. So this one's called remove element. Given an integer array nums and an integer val, remove all occurrences of val in nums in place. The relative order of the elements may be changed. Since it's impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing duplicates, then the first k elements of nums should hold the final result. If it doesn't matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of n. Like that. We want to return all, we want to remove all occurrences of 5. Then these will remain unchanged. This element will get left out. So what we'll end up having to do here, I mean, let's just think about this. Okay, so let's say that our last successful place would be 0, then 1, then 2, 3, 4. Our last successful was 4. This is not successful. Is this successful? It is. So the last successful was 4. We're just going to swap these two elements there. Going to keep going, so on and so forth until we get to the very end. Essentially, what we would have then would be have a list of sorted elements at that point. So I think that that's actually a pretty good way of going about this problem. So I could say last successful would be 0. You're going to say for I, comma, value in enumerate nums. You're going to say if value equal to val, then else you're going to say if I is not equal to last successful, let's think about this. So if I is not equal to last successful, which 0 and 0, it is equal, but in this case, I is not equal to last successful, then, so if I is not equal to last successful and nums sub last successful plus 1 is equal to val, then nums sub last successful plus 1 equals value. We need to go ahead and save a temporary value. Temp is equal to nums sub last successful. I don't think that this is really necessary because you know what it is. It's the value that you're testing against. I'm essentially just doing a swap here. And then you're just going to say nums sub I equals temp. Okay, then you're going to say last successful plus equals 1. Else, okay, so I is equal to the value. Ooh. Okay, so this can actually look like this. Okay, so let's work through this problem really quick. So of the logic that I have right now, you're going to start off with 0, 1. If 1 is equal to, in this case, what would it be? 5. It's not, so it's going to continue on. It's going to say if I is not equal to last successful, so 0, 0. Okay, so I was giving this one some more thought, and I think I have a pretty simple solution here. I think that I'm overcomplicating things quite a bit. So I think what I need to do here is just say for I in range len nums. Okay. If nums sub I is equal to val, then I'm going to do a while loop, and I'm going to say while I first of all you're going to say j equals I, and you're going to say while the length, while I is less than the length of nums minus 1, and nums sub I is equal to val, you're going to say I plus equals 1. Okay. And so now essentially what you should have is you should be able to say nums sub j is equal to nums sub I. Nums sub I is equal to val. But the first thing that you want to do is you want to say if I is equal to the length of the list minus 1 and nums sub I is equal to val, then we just need to return nums sub up until j plus 1. Okay. Now we can just return, if we get all the way out here, return nums sub j plus 1. Two, 2, 3 is not a valid value for the expected return type of integer. Okay, if I just do that. Type error. Blah, 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 blah is not a valid return type of the expected type integer list. I mean, what if I just do this? Just return nums. Same thing. Return nums. Two, 2, 3. Okay, return k after placing the final result in the first k slots. The hell is k? More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter beyond that point. Return k after placing the final result in the first k slots. Oh. Like what? Num sub j? What are you talking about? Raise type error is not a valid value for expecting type integer array. I mean, I'm freaking confused here. Your function should return k equals 2. Output 2 comma 2 comma nums equals that. What? Expected the answer with the correct length. Okay. Int k equals this. Calls your implementation. Assert k is equal to the expected length of the list. I mean, how is it just not j then? Come on, give me a break here, man. In the event that it doesn't contain anything, then j is equal to the length of the nums minus 1. Okay. The hell? So let's look at our test cases here. I want to pass in 1, 2, 3, 4, 5, and 6. Or I'm sorry, 6. And I want to remove all 7. Let's see if this passes. So it should return that. J is equal to the length of the list. Length of the list. What about that? Okay. What are some constraints here? 0. Length of the list can be 0. So what happens if it's this? Does this fail? Okay, so that passes as well. What happens if they're all the thing? Okay, so it's definitely not the most efficient, so I'm not going to try and sit here and claim that it would be. Is there any way that I can go ahead and try and get this marked down? Like, how can I get this to go down? Oh, just like that, actually. Okay, so I'm not going to sit here and try and claim that this is the most efficient way to do this problem. But honestly, it is pretty efficient. So it's 49 milliseconds. And, you know, if I were to sit here and run this again, it'd probably be a different number again. Yep, and now it's slower. And then if I hit it one more time, I've done this a couple of times in the channel where it's just dependent on how performant it is within their server that is actually hosting this. So yeah, like look at this now. Now it went all the way from 24% all the way up to 74.4%. But like just efficiency wise, let's go ahead and talk through this stuff. So you're gonna go ahead and set j equal to the length of the list. So that's gonna satisfy that we're looking for an element that does not actually take place in the list at all. So that way, as we iterate through, then we at least can say, yep, go ahead and just return the list as is because it's not in here. Otherwise, as soon as it comes across that value at that index, you're going to set j equal to the index, and then you're just going to continuously go ahead and bump up I. And then you're going to say, okay, am I at the last element in the list? And is the last element in the list equal to val? If so, then just return j because you know that you've kept on going through this requirement here. And that while loop's going to break as soon as it meets that first non-val value. And so if you did hit this and it's equal to the thing that you're looking for, you know that everything from the point that you started in the while loop till the end is all that target value that you're trying to remove. Otherwise, then you can just go ahead and do the swap at those two positions, and then you can proceed as follows, going down the line as such. So what I could end up doing, honestly, is going ahead and taking all of the values between so and then pushing them forward, so that way I can just set I equal to whatever, and like I'm basically hopping over everything that's not valid anymore. I'd be able to understand where that would be and where that would lie. But anyway, I'm just going to go ahead and return J as it asks for. It had its own little set of rules to try and validate against. But that's going to do it for today's video. As always, if you like today's content, feel free to like, comment, subscribe. Helps me out a ton, and I'll catch you in the next one. See ya.